everybody. This is Eugene Liscio. I'm the founder of AI2 3D. I'm a 3D forensic analyst, and what I do is I use 3D technologies in the documentation, analysis, and visualization of crime and accident scenes. So this week I'm going to be talking about software, and I want to go through the basic process of what happens in the software. Now, there are many different software programs out there that I could mention. There's a big long list, Metashape, Capturing Reality, 3D Flow, which is 3D Zephyr, Photo Modeler, ElcoVision. The list goes on, and there's a bunch of other ones, including free ones and some very expensive paid ones, like Pix4D, for example. Now, there are a number of different ways, I guess, of doing something, but each of these software programs has more or less the same flow or the same workflow. And if you can understand the workflow or the basic steps, it kind of gives you an appreciation for how to take the photographs and what you're going to be able to get out of it in the end. So let's start with that. Now, when we have our photographs and we import them into the program first, okay, the very first thing that needs to happen is that the program needs to do some feature matching. So feature matching is that it's going to go into the image and it's going to be looking for little details of high contrast or color differences, and it sort of labels a number of different features on an image. And it's going to bring in 50, 100, as many photographs as you will throw at it, and it's going to do the same thing to each image. Now, what it does after identifying these features is it does a match. So it takes a number of different photographs and it's going to look for a particular point on one photo, and it's going to see if it can find the corresponding point on the other. But it does it for thousands of points. So when I was talking before about the manual process of matching different photographs, that's something that people had to do before. But now, because of these automated algorithms, it'll do thousands and thousands of points on the multiple different images. So that brings up a really interesting point, and that is that you need to be able to find features. And that's why when taking photographs of an object, it needs to have differences in texture, bright and dark. If you took a picture of a white wall and everything is just kind of white and blank and there's really nothing on it, if you take 4 or 5 photos, there's nothing to match. So it's not going to do a very good job. So this is an important point of photogrammetry, right? Is understanding how you can bring out more texture and kind of understanding what the limitations are. Sometimes it's just not going to work for you. So after you do the matching process, really what's happening when it finds where all the different common features are is that it does a type of matching or type of resection where it figures out where all the camera positions were. So in the software, you'll see that it's got a number of different positions for the camera if you were moving around an object, and it figures out where the camera locations were. And that's really, really important. And it does this relatively quickly, believe it or not. If you have even 100 photos or whatever, it does a pretty good job of doing that. So feature matching and figuring out the initial camera positions will produce something called a sparse point cloud. And that's really just all the points that it used, all those feature points that it used initially, and it knows where they are in 3D space. And it uses those points to figure out the camera locations. And you sort of have a very thin point cloud of points that it's been able to match together from a whole number of photos. Now, sometimes it doesn't work for all the photos, but it will do its best to do as many photos as possible. Now, that's sort of the first step, and there's obviously some multiple things that are happening there. The second step is the dense point cloud. So what you want to do at this point is, once you have all the camera positions established and it's figured out kind of where everything is, you can tell it to go in and look deeper. So it'll start looking now at the deeper pixels and start to create a dense cloud of points between all the photographs. And of course, this only works where you have 2 or 3 images or more which are overlapping. So if you have a single image that's kind of hanging out on its own, it doesn't really do much for you. You have to have multiple images, multiple overlapping images, and it can pick off some of the dense point cloud in that particular area. So once you have a dense point cloud, okay, the next thing you're going to want to do is probably mesh it. So if you want it to work with just a point cloud, you can stop right there. That's not a problem. But oftentimes it's better to produce a meshed surface. So many of these photogrammetry programs will have a function inside where it'll take the point cloud and it'll thin it out and create a nice mesh. And you can think of meshing as sort of like draping a sheet over a cloud of points or something like that. And it helps to lighten the load, let's say, of the model, and it allows you to do something else on the back end, which is texturing. Now, texturing really makes the model pop. It really gives it the photorealistic look that you'd like to see. And what it does there is it goes back into the photographs, it pulls all the original color texture and it puts it on the mesh. So the point cloud data is sort of the matched pixels and it picks off the color from those matched pixels. But when you do a mesh, you actually have like a small patch, and what it'll do is it'll go back, look at all the different images, pull off the best color for that particular area, that small area of the patch, and then it applies that. And that gives it a really, really nice effect, or makes it a really photorealistic model. And if it's done properly, you'll have the textures and the colors in the exact locations that are necessary. Now, one of the advantages of texturing are that sometimes, especially at a crime scene, if there's like a fluid stain or something like this, it doesn't necessarily show up as geometry. So it doesn't have thickness, it doesn't have contour, but it's just a dried stain on a floor, for example. But if you have texturing, you'll be able to see that and it will be accurately placed on the model so you can take some measurements. So that's the basic process right now. You've got the feature matching, you've got dense point cloud, you've got the meshing, and then you've got the texturing. And there's other things that you can do. For example, you need to scale and orient the model and stuff like that. But those four things are really the basic process for any particular project.